We're getting to another part and another term, and that is crucial term. Now it is really crucial for ABB, and that is hyperventilation. And what is hyperventilation? Tell me. What is that? What is? Yes.
Like when you increase the rate of respiration.
Okay, so increased rate. So there's a better term to describe this, and it's called tachypnea, isn't it? So I want you to understand something very clearly now. It's not tachypnea. It's not precise. So you are right. People typically, when they hyperventilate, they can really breathe fast, but it's not correct fully. So some other suggestions. What is?
Isn't it release of CO2?
I'm sorry.
The increase, like release of CO2.
Very good, guys. Watch out. Some say also deeper breaths. Yeah, that's what you see, but you cannot be sure it's hyperventilation. So from today, please remember, hyperventilation is defined by partial pressure of CO2, nothing else, only that. Because there, you know, so basically you have to, the pattern, the breathing pattern, whatever the pattern could be, like breathing fast, okay, so frequency is increased, or whatever the pattern is, doesn't matter, pattern. But the important thing is you breathe whatever the way, you can breathe fast or deep, or combination of both. But the important thing is you are exhaling more CO2 than before you started this pattern. Okay? And when you do this, you can call it hyperventilation. Okay? Okay, so you have to get rid of CO2. So you have this breathing pattern causes hypocapnia. And when this breathing pattern causes hypocapnia, or like drives the CO2 lever before you start it and it goes even lower. So if it makes this change, CO2 goes lower than before, then you can say now that he hyperventilates, okay? The dogs. How do they cool themselves? Because they don't have sweat glands, so they, open their mouth, put their tongue out, and they breathe very fast, yeah? They breathe very fast. It's evaporation from the tongue and from the mucous membranes. So that's how they're cooling themselves. But tell me, is this hyperventilation or not?
No, because they're not decreasing the amount of partial pressure of CO2.
Yes, because it's a shallow breathing. They're ventilating only the dead space, and that's why panting is not hyperventilation. Watch out. So they have tachypnea, but it's so shallow, so they're not changing their CO2. Okay, understand that? In other words, hypoventilation again describes only it tells you that you're gonna, if you have some certain levels of CO2 and you in arterial blood and you start to breathe, you're gonna stop breathing, getting rid of CO2, and the CO2 will go up. Okay? Yep. But important question, what about O2? How is it with O2 and partial pressure of oxygen in arteries again? So if I'm hyperventilating, will I change my, if the oxygen is normal in the air, like let's say the ratios of the different gases are normal, I'm breathing normal air, and with normal partial pressures, it can only slightly increase, but rather you can say it will stay the same. So O2 sort of, you cannot boost it up by ventilating. How can you boost up partial pressure of oxygen in a patient? How would you increase it?
A ventilator?
No. If you put him on a ventilator, you won't increase it. If everything is okay and he breathes normal air, you won't increase it. That's the same as if you would try to breathe a lot. You will get rid of CO2, but you cannot increase O2 more. Take the lungs that they're very much like they are so well tuned for these regular, normal, let's say, occasions and the partial pressure of oxygen in the air. So they're very well tuned for air at the level of the sea. But how would you increase it? And I helped you with the sea maybe a bit. The only way how we can really increase the partial pressure of oxygen is
Hemoglobin?
no. You want
pure oxygen?
Yes, you give more and never give pures totally. That's pretty dangerous. But well, you can for a short time, but you give higher concentration of oxygen, of course. And remember from today, with changes of hemoglobin won't change partial pressure of oxygen in the blood. Watch out. They won't change that. Okay? It's about the air you're breathing. Yeah, so the only way how to increase O2 immediately is giving more oxygen.
What if you give some dilators, so the
Dilators?
of the bronchus or the alveoli?
No, oxygen. The person has to increase higher concentration of oxygen. That's the only way how to increase partial pressure of oxygen in the blood.
I'm sorry, but doesn't a ventilator pump oxygen into the lungs?
Well, you mean, okay, but I said normal air, when you're breathing normal air. Yes,
Okay.
Okay, so of course, if well, it depends, yeah. But then you're changing the concentration of the air, that's what I'm saying. But if you're going to ventilate with someone more, and you're going to ventilate with normal air, you won't increase the partial pressure of oxygen. In the more than normal, I mean, okay? If it's 100, it won't go over by changing the ventilation pattern. But the other question is hypoventilation. So in hypoventilation, obviously, I ventilate in a way, I ventilate slower or shallower or combination, whatever, that the CO2 goes up in the blood. But how is it with O2?
O2 will be going, will not be changing either.
No, it's going to go down. Definitely. You stop breathing. That's hypoventilation. If you stop breathing, CO2 will go up and O2 will go down. Okay? So watch out. There's a big difference. Hyperventilation, O2 will stay normal. CO2 goes down. Okay? This and this. But watch out. This and this. Okay? Yep. Hypoventilation. Good? So very important. And when hyperventilate, we're going to talk about causes, but so basically hyperventilation, if you're decreasing CO2, the synonym to hyperventilation means respiratory alkalosis, and hypoventilation means respiratory acidosis. Yeah? Okay? Remember the equation. Okay? Yeah? Good? pH. Yep. So hyperventilation means I'm causing respiratory alkalosis. Hypoventilation means I'm causing respiratory acidosis. That's it. There's a name which talks about respiratory alkalosis. There's a name you know from previous years from physiology. What's the breathing pattern you call? And it's the same. It means
The
Very good. Kussmaul's breathing pattern. Kussmaul's breathing. Kussmaul. It should be Kussmaul with L at the end. Kussmaul breathing. Kussmaul breathing means hyperventilation. Basically, it means hyperventilation as a reaction to acidosis, metabolic acidosis. So in case you have buildup of lactate or buildup of ketones or anything metabolic, you compensate with hyperventilation that you can call now Kussmaul breathing pattern. Yeah, that means they breathe fast and deep. That's Kussmaul, okay? As a compensatory reaction to metabolic acidosis. So every time you have metabolic acidosis and your lungs are functioning well and your brain still is also, you will hyperventilate. Okay? And other causes we'll talk later. Okay? So compensation. Okay, what about buffers? What about buffers? So what buffers we have? That means those are substances in blood that are able to very fast compensate the changes of pH. And what are the buffers?
We have blood, we have extracellular, and extracellular.
Yeah, so the extracellular, well, intracellular we talk about one. There are more, but extracellular, the most important are which ones? So you should start with bicarb.
Proteins?
So bicarb, first of all, bicarb, that's the fastest and most powerful, but very good proteins. And you can mention it's a protein as well, but so hemoglobin. And fourth one is?
Phosphate?
Very good, phosphate. And I will try to make it, oh, this is thinnest. Phosphate. But remember, phosphate is much more, and the main one intracellularly, yeah? So, but this is extracellular. So these are, the buffers very well, okay? But now I want you to name me, and we call them compensatory systems or compensatory mechanisms. So for pH changes. So now we are talking about some systems, ABB or pH systems.
Would be the kidney and the lungs.
Very good. And not only these, but these are the main ones.
The heart as well.
Yeah. What?
The heart, the liver.
Well, I don't think heart is so much important. Rather, it takes everything. But yeah, I'll tell you. So yeah, you're right. Also, heart could be like basically any cell. Okay, but watch out. So first two main ones, the major players, and you said right. It's our lungs and kidneys. Yep. So kidneys, and there are slight differences or major differences between these two. So first of all, lungs react immediately. It's an instant response to metabolic changes of pH. So if there's a buildup of acid, I will hyperventilate. If I'm going to be alkalic, if I vomit and get rid of acid, I will hypoventilate in a way. Okay, so they respond immediately, but they are not as good compensatory mechanisms or buffers. You can call their buffers in a way too. So, and they are not so powerful as kidneys. So that's why they will not fully, if there is a problem with kidneys, for example, and you're retaining acids, they will not fully normalize pH, because every time the pH normalizes, they will stop hyperventilating. Okay, so it turns them down. So you cannot fully compensate that. And one speed, that's important. One speed. Okay, you just turn them on and off. In contrast, kidneys, they have two speeds. So for example, someone has COPD. So he's not able, and it's a great example. COPD is a great example of respiratory acidosis. Okay, yeah. So when you're having COPD, then, and it's a chronic thing. So when you start to having, okay, if you hypoventilate for whatever the cause and you're having respiratory acidosis, first kidneys start slowly, and they have to totally rebuild themselves, and this takes like 3 days. Okay, this takes 3 days. So in the first days, it's a slow speed compensation, and then there is a fast speed. After 3-4 days, they totally rebuild. It's on the cellular level and the channel level. Okay, so the cells in the kidneys, they're totally rebuilt. They make different channels, and they start to react to the acidosis typically. Okay, so that's why next week you're going to learn 6 formulas actually. 2 formulas for alkalosis, acidosis of the lung, like compensation by lungs, and then you're going to have 4 more formulas for kidneys because it depends if it's acute compensation or if it's chronic. Okay, yep. So another important compensatory system are cells itself, because there's exchange of K plus with H plus, and it goes both ways. Watch out. So basically, if you have acidosis,
Isn't this in the kidney itself? Shouldn't be a part of kidney?
everywhere, it's everywhere, this exchange. Remember, H plus and K plus works on every cell. So every time you're having hyperkalemia, or in this case first, if you're acidic, your pH goes down, you have lots of H plus in the extracellular space. The H plus gets into the cell, and H plus gets into the cell and pushes out K plus. So it works the other way. Also, in case you're having hyperkalemia, the potassium gets into the cell and pushes H plus out, and you're having acidosis. Okay. Yep. So remember, there are very similar ions, potassium and hydrogen, and they, in most of the cases, they sort of takes each other place. Okay. Like people in a tram, fighting for one chair. Okay. Yep. Okay. So remember that. And it's a powerful. We can talk about that as a powerful compensatory system. Okay. 4. Remember liver. So if I would draw liver over here and like this, well, this is not a nice liver, but so liver. So remember, liver also has like 2 ways. It can switch on and off 2 systems, and if you have alkalosis, you're gonna produce. You're gonna first of all, if you have alkalemia, pH goes up, then you're going to produce urea plus 2 protons. And in case you are acidic, okay, you produce glutamine and NH4, and this is the thing you will get rid of in kidneys. Okay. Yep. So in one case you're producing urea and H plus in case you are acidic, and in other one if you're alkalic, and so it's alkalosis. So that's why you are increasing the H plus over here. And in case you are acidic, you produce glutamine and you get rid of the H plus over here through the kidney. So you pee it out, the H plus. Okay. So those are liver. And last system that I would mention over here are bones again. And every time you have acidosis, remember pH goes down, you exchange H plus with bones. And especially with what ion? What would you think? Remember sodium. Okay. So you are getting rid of sodium from the bones. And again, Remember we talked about kidney failure? That's when the pH goes down. You are acidic, and this is another way, that another mechanism you can put under renal osteopathy. The acidosis itself kills the bones, okay? So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.